Hi everyone, welcome to my channel. In this video, we'll be talking about how the B-2 bomber almost couldn't be built due to failures in engineering. Please remember to like and subscribe. Alright, Fact 1. Wing bending. So as you know, the B-2 is a very complex engineering marvel, and it took a lot of complexity to make a flying wing. And during the building process and design phase, the engineers didn't have full up-to-date structural analysis ready at their disposal. And so as a result, they continued with the design that introduced a significant wing bending. And because the whole aircraft is essentially a wing, you're talking about bending the whole aircraft during types of maneuvers that were at high speed and low altitude, and also the controls to alleviate low elevation while still trying to maneuver the airplane. 80% of the wing bending moment came from the first bending mode, which had a nose line behind the outboard controls. This was a significant problem because that would really change the structural dynamics of the aircraft and make it completely unstable. The engineers weren't able to understand this until very late into the design process when they were just about to finalize the design. Alright, Fact 2. Asymmetric load distribution. As you know, for aircrafts, the load distribution is extremely critical. If you have too much load on one side, it will impact how you can control the airplane. For example, if too much weight is in the front, you may not be able to lift the plane up. Or if too much weight is in the back, you might struggle to keep the plane pitched down. And for the B-2, when they were doing the analysis design, they saw that the forward weapons bulk bay, as initially designed, would have carried over 70% of the load, whereas the rear bulkhead would have only had about 30%. The combination of this poor load distribution led to a very poor design that really impacted how the plane could maneuver and stay afloat. As you can see, it was a huge problem, especially in aerodynamics and airplane maneuverability. And so the engineers had to quickly figure out how exactly to redistribute the load evenly. Alright, Fact 3. Control instability. As I mentioned in the previous two sections, the problems introduced toward the very late design phase of the B-2 bomber was a significant setback for the program. Because these problems that were identified later due to the lack of structural analysis and aerodynamic analysis that should have been really completed before the design process was undertaken. Unfortunately, because they moved forward in parallel, the engineers didn't really get a full picture of how the aerodynamics and the structures can change in certain conditions, for example during high gust winds. And so they were confronted with all these issues toward the end of the design phase when the design was just about to be locked down and sent for manufacturing and production. In addition to wind bending and asymmetric load distribution, they also identified inadequate control surfaces on the trailing edges where it controls both the pitch and roll of the aircraft. They found significant problems when the aircraft's pitch instability yielded an open loop time that necessitated immediate controls from the control surface and needing a much larger and high rate of services. Alright, let's get into the next fact. Fact 4. Inlet design. As you know, the major requirement of the B-2 bomber was the stealth capabilities. And the inlet is essentially where the engine intake is. Similar to the first generation stealth aircraft, the F-117, the design had to hide the engines within the body of the airplane so that it could reduce its radar signature. And so for the B-2, because the initial designs were conducted without thorough structural analysis, the inlets were designed as a simple hidden component behind a thin layer of radar absorbent materials. This also posed significant challenges with the baseline configuration. The vane design was understood to be lacking in terms of the way it could handle various load environments. And so as a result, they needed additional changes to the structure of the inlet vanes in order to understand how it could potentially make the aircraft a lot more stable. And so what you see on the aircraft itself today was actually not the original design, because the original design had significant flaws, including the inlet vane section, that impacted the structural integrity of the aircraft during high stress and high load situations. The inlet pressure recovery and distortion had to be rethought. Alright, let's get into the next and final fact. 1-year delay and cost overruns. As I mentioned in the previous sections, all these design flaws were not identified until very late during the design process, just about when the designs were to be manufactured into production. And so the engineers and the production program managers had to scramble and conduct thorough reviews to revise the design. They needed to rearrange so many components of the B-2 aircraft in order to accommodate what they found to be inadequate and dangerous for the aircraft. As a result, the whole program was delayed by over 1 year in terms of the first flight test. And in addition, because you need to pay the engineers and the program managers, there were significant costs that were unforeseen and added on top of the overall program costs. Of course, they didn't give up, and as you know, the B-2 was successfully designed and deployed as of today. Alright, that's it for my video today. Thank you so much for watching. Please remember to like and subscribe. See you next time.